Hello and welcome back to Friday Minis. Binary. If you've been dealing with computers, if you've been learning computer science for a while, this shouldn't be new to you. The idea is that, well, we have bits, right, and we can string the bits together to represent data, things like numbers, things like text, and so on. The traditional way, the most simple way that we deal with binary digits, where each digit represents 1, 2, 4, 8, and so on, is of course the most straightforward and intuitive way of representing values using binary. But as it turns out, that is not the only way. Today, we'll look at binary coded decimals. The idea is, in this scheme, we're trying to represent individual digits, right? Decimal digits, so 0 to 9, using some combination of binary digits. Of course, the simplest way would be to stick to the original. Essentially, we'll need 4 bits, right? We definitely need that because 3 bits isn't enough. Of course, certain combinations are so-called wasted, right? We don't really use it in this context, but that's fine. And yeah, each position simply represents what it normally represents, and we'll get our decimals. We call this 8421. Essentially, that represents what each binary digit actually represents, right? So 8421 from left to right. But as it turns out, there are other schemes. Here's one that's pretty interesting. It's called the Eigen Code. And instead of being 8421, it is 2421 instead. And this BCD scheme actually exhibits some interesting properties. But before we go there, let's try and understand how this works first. The idea is, instead of having an 8 in this column, we now have 2, right? So let's say to make up the number 7, it basically still works the same. We take 2 plus 4 plus 1, right? And that gives us 7. If we wanted 8, well, we'll switch out this 1 for this 2, and that gives us 8. So the way in which this works is exactly the same. Whenever you see a 1, you just sum the values in the corresponding columns. What this means is, yes, certain values are actually doubled up. One very simple example would be, say, 2, right? I could choose to use 1, 0, 0, 0, that would give me 2 as well, right? For 3, I could use 1, 0, 0, 1, and that technically gives me 3. However, the Eigen Code is set up with a specific purpose in mind, and that is the numbers from 5 to 9 are designed to be mirror images of the numbers from 0 to 4. I'll show you what I mean. You see, at 4, it is 0, 1, 0, 0, right? For 5, it is essentially just an inversion, a not, of this value here at 4. So you flip all the bits, that gives you 5. When you get to 6, you're essentially flipping all the bits of 3. So on and so forth, right? All of these actually correspond to each other, like a mirror image. So yeah, when actually picking a scheme for your BCD digits, it actually allows you to, well, create special properties like this one. At the end of the day, as long as, the 4 digits allow you to produce all the numbers between 0 and 9, then you have a valid BCD encoding. This, by the way, includes negative numbers. Another very interesting scheme is 84 minus 2 minus 1. That's right, 2 of the binary digits actually represent subtraction. What this means is, to represent 1, you will take 4 and you'll subtract both 2 and 1, and that gives you 1. So yeah, it's an interesting way of representing numbers, right? As it turns out, our traditional 8421 isn't the only way. Any combination works as long as you can represent all the digits, and this is called binary coded decimals, BCD. That's all there is for this episode of Friday Minis. I hope you've gained some insight today, but until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.